Morning everybody, and my apologies for not here being with you in Madrid. This morning we're going to be talking about quantitative weight of evidence and how that could be applied to Omics data. I'll start by giving a general introduction about quantitative weight of evidence, and then Professor Jim Bridges will come in and explain how it can be applied to Omics data per se. Now, we all make thousands of decisions every day of our life. Many of these decisions are without significant consequence, so we rarely labour over them, often referring to intuition to guide us. But it's only when the consequences of our decisions have significance that we invoke rational deduction. Now, as scientists, we're expected to make rational deductions that are both transparent and scientifically justified. And failing to do this, we lose the trust of the scientific community and other stakeholders. Now, when making these decisions, we rarely have the luxury of considering a single piece of evidence, since often a decision is made in the context of a much wider framework. Despite this, we tend to default to making decisions based upon a strength of a particular line of evidence, without considering the contribution of other related lines. So why do we do it? Well, it may be because we wish to be precautious, or quite often it's much simpler. Now, I contend this is often because we don't have a recognised framework within which to rationalise these divergent lines of evidence and quantitatively weigh their contribution to the overall assessment. Now, we should recognise that there are many initiatives in this area, so it's necessary to establish a working definition at the outset. Now, we have defined quantitative weight of evidence as the testing of a hypothesis or a problem formulation by the critical weighing of all suitable, relevant studies using predefined, scientifically justified, scored criteria for both quality and relevance to characterise quantitatively the strength of the evidence. Now, you'll no doubt have heard about systematic review in the context of evidence-based medicine, and in particular the methods developed by the Cochrane collaboration. Well, quantitative weight of evidence and systematic review have a lot in common. Indeed, quantitative weight of evidence, at least as we have applied it, assumes systematic review, but then goes further by providing a framework within which different lines of evidence can be weighed for their relative contribution to the decision-making process. Now, we've developed a framework of 8 steps. The framework that we are proposing draws upon the experience gained over the past 20 years in applying quantitative weight of evidence and systematic reviews, and more recently within the context of REACH, categories, read-across, and the European Chemical Agency's read-across assessment framework, or RAF, and the associated guidance. Step 1 is the hypothesis definition, and it's critical to establish the hypothesis in order to be able to collect the necessary relevant information used in the assessment. Step 2 is the quality assessment, and this addresses the reliability of the study design, including the identification and characterisation of the effects. Step 3 is the relevance assessment, and this addresses the relevance of each finding, including such aspects as the model used, the exposure conditions, dose response, statistical significance of changes, historical controls, benchmark comparison, and also reversibility, and most importantly, consistency between the endpoints. Now, step 4 is the assessment of the criticality of the endpoints to the development of the disease or toxicity in the species of concern. Step 5 is the assessment for intra-LOE concordance. So that is the concordance between findings within a single line of evidence, together with the justification of non-concordant findings. Step 6 is the assessment of inter-LOE concordance, i.e. the concordance between findings between all studies for different lines of evidence and their plausibility. Now, this may involve further evaluation based upon effects of no modifiers, AOP support, structure-activity relationship, or other factors, and again it should include a justification of any non-concordant information. Step 7 is the read-across or benchmarking activity, which includes comparison with findings with related chemicals. And finally, step 8 is the conclusion of the assessment outcome, whether it's a risk assessment or a hazard assessment, and the characterisation of any uncertainties. So in summary, the quantitative weight of evidence framework being proposed is generic in its applicability to almost any hypothesis. It can provide transparency of process, thereby hopefully minimising opportunity for bias and providing a basis for dialogue between stakeholders. Now, as the title suggests, it can also be quantitative if tailored scorecards are developed by subject matter experts. Now I'm going to hand over to Professor Jim Bridges, who will give an example of how this framework can be applied to omics data. Thank you.
Mark talked about the use of quantitative weight of evidence for assessing data for risk assessment purposes. What I want to do is talk about the application of quantitative weight of evidence to omics data. With omics data becoming increasingly part of risk assessment, we need to have a way of introducing it to make it compatible with the way we treat traditional data. The main aim of quantitative weight of evidence is the same for omics data as for anything else. We want a scientifically based method that's objective, is transparent, and it's consistent. But for omics, there are particular issues. How do we relate omics data to traditional endpoints for each effect of concern? What about different categories of omics data? Do we give them all equal weighting? Can we compare omics data across different lines of evidence, for example, human, animal, in vitro? And how do we interpret changes in omics data, which inevitably you're going to see, as to whether they're adaptive or whether they're adverse? The methodology for omics, of course, is very similar to that Mark discussed for generic substances. You start with a hypothesis or an effect of concern, and then you look at the lines of evidence that are required to investigate whether that hypothesis is justified or not. You choose the different kinds of endpoints that you think should reflect that effect of concern, and you look for literature that is going to identify relevant papers and reports. Then we have to establish best practice methodology for each line of evidence for the effects of concern. We have to develop scoring systems for both quality and for relevance of those reports and papers. And then finally, we need to score each of those papers and reports for every line of evidence for both quality and relevance, and calculate an average score. And lastly, we have to put all those lines of evidence together, and we have to make some sort of weighting for different kinds of evidence and combine those to see whether the hypothesis is supported or not, what the uncertainties are, and whether they're acceptable or not for risk assessment purposes. For quality, we have a range of factors to consider, because what we're looking at is whether the experimental design is appropriate, whether the chemical is added in a suitable way, whether the measurements are suitable, whether statistics are appropriate, and a number of other factors as well. All those are crucial for quality, and we derive those, as I've said before, by looking at best practice methodology. Then we come to relevance. And of course, the factors for relevance will depend on what we're trying to look at in terms of the hypothesis, whereas the factors for quality will not vary quite so much. But fundamentally, we're looking at, is there a dose-response relationship? Are the profile of endpoints comparable with the control group or with benchmark chemicals? Is the effect persistent or not when we stop dosing? Are the results consistent for each type of endpoint? So is there consistency between omics findings, for example, and traditional findings, or between different types of omics findings? And largely, can we transfer our understanding of the endpoints in the system we've been looking at to comparable ones in man? The biggest challenge at the moment is to try and identify how we score for relevance if we have only endpoint data, because omics work is rapidly developing and changing. But there are four basic categories. Is the pattern of changes like well-established benchmark chemicals, where there's some reliability of the linkage of omics data to the effects of concern. Are the omics data consistent for critical points in the adverse outcome pathway? Third situation is that omics changes are found, but it's not clear what the relevance is to the effect of concern. And lastly, a situation where we've got inconsistent changes in omics findings, and it's unclear whether the omics changes actually represent an adverse effect. And finally, the biggest challenge of all, combining all of the lines of evidence in a scientifically justified and transparent manner. There are a number of situations. The simplest, of course, is where you've got both omics data and traditional endpoints, and they're all mutually supportive. Inevitably, that has a high score unless we have substantial uncertainties because the data is insufficient in nature. Then we have a situation where some differences are found, but we've got a reasonable justification for those particular differences. Those two situations are straightforward. The challenge comes where you've got major differences between omics data and traditional endpoint findings, but within the omics data, the endpoints seem to be consistent. And that's the area that needs to be worked on. So where do we stand with the use of quantitative weighted evidence for assessing omics data? We've got a framework which looks robust. We've got a number of areas to look at critically in terms of the details. And then we need to apply the methodology we've developed to particular examples to see whether it's valid in practice. We hope to start that in the next few weeks.